Okay, this is without the benefit of my master cameraman, so here goes. So this is question 4 on the mock exam, in the folder mock exam presumably. I've got all my equipment, unlike you lot in the exam, so I've got a ruler and a calculator, pencil, pen, hey, it's not rocket science, is it? So, and here we are with more plant material to look at. Do you like a plant? So, question 4. Wheat grain size is determined by the plant's genetics, i.e. variety. So, I'm thinking there already, before I even read the question, that this is about variation and not about plants. And the length of the grain filling period. Plant breeders cross varieties of wheat in order to increase grain size. The photograph below shows the results of a cross. Now obviously in the exam, this was a coloured photograph which made it a little bit clearer. So they are different colours which you can't really see on a black and white picture. I mean, that one looks lighter, doesn't it? But it could be anything. Anyway, so what do we need to do with this photograph? Distinguish between continuous and discontinuous variation. You should give an example visible in the photograph. So it means it's something you can see on the photograph. So obviously I'm not going to comment on colour because I can't see it on that photograph. However, what I can see is these little hairs at the top. So they've either got really long hairs or they've got really short hairs. So that's a discontinuously varying characteristic. So my discontinuous example is hairs, and my continuous would be something like, they're all different lengths, they're all different widths. Example. And that lengths and widths are generally a good example to use. They tend to be discontinuously variable. But it's for 3 marks, so that's only going to be 1 mark, an example. And so I need to say something about each. So continuous is where a characteristic shows a gradation. You could put that as lots of intermediates. I'm going to put gradation from one extreme to another. I think it's a better way of putting it. And controlled by many genes. Now in the exam, and we did spot quite a few of you doing this, writing outside of the box. Now here it's not so bad because actually the examiner can probably look at the whole paper. They know that you've gone on. So as long as you don't leave too big a gap, they'll know that you've written something else. The difficulty comes where you put an asterisk and we don't know whether it's an asterisk that you've made as a note on the paper to go back and have another look at that, or whether it's an asterisk that tells us that something else has been written somewhere else. And of course if you put an arrow somewhere saying, oh, my answer is up here, well, we can't see that at all we can see is what is in the box on an online marking, because they're scanned in and that bit's, this bit is cut off, so you can't see anything over here. That's just lost, that's in a shredder somewhere. So anyway, continuous and discontinuous, I'll come back to that and to do a little what I found out in the exam today video. So discontinuous, this is where characteristics clear cut and they're controlled by one gene. remembering that might have lots of valuables. Okay, jolly good. Now the other thing, so again I'll come back to this in the video, this is a blank page. They don't put these in for padding, they put them in because when you turn over, it means that they want you to use information on both sides of the paper. And if you fold your paper over, I saw loads of it. Well, in fact I can tell you how many people I saw doing this, but loads of you had your paper folded up like that. It's the first thing you did, fold up the paper, and then you don't see the links. So don't do it. Leave your paper lovely and open. I don't know how many times I need to say it. Okay, so total what? The graph shows the distribution of grain length in a sample of the hybrid wheat. Grains are measured to the nearest 0.01 millimetre. So, first question, what is the total number of grains in the sample? So first of all I need to work out my scale. So 2 of these little squares equals 1. So that's 9 there, frequency, number of grains, 9 of them, plus 6, plus 25, plus 15, 16, 17, plus 20, plus 10, plus, I hope you're admiring my nails, plus 5, plus 2, 100, about 100. The student calculated 3 different averages for the length of the hybrid grains. The mean was 6.57, the other 2 values were 6.45 and 6.52, so one in there and one in there. With reference to the graph, state which of these values is more likely to be the mode and give a reason for your choice. So the mode is the most frequently occurring value. So the most frequently occurring value is between 6.4 and 6.49. So the one that we're going to choose then is 6.45 millimetres. Give a reason. Because it is in the most common class of values, and I'm going to say what that is because I can. 6.4 to 6.49. There we go. You could approach it the other way, of course, and say it's 6.45 because the median would be the 50th value, which would be in this box here. But that's a bit more of a pain to work out, really. So, what evidence is there from the graph that the length of hybrid grains is not normally distributed? So, you sketch a normal distribution. The key feature is that all those 3 averages, mean, median, mode, they're all the same. So, why is it not mean, median, and mode are not the same? If they were, it would be normally distributed. You could have, I guess, gone for the it's not symmetrical, it's not bell-shaped. A bit of a weaker answer, I think. So it tells you that for each parental variety, the mode and median were the same. Arrow X, so that's this one, shows the mode and median for parental. Look, cameraman's back. He's just going to check that actually you can see. Oh, he's passing me a colour photograph, but I'm not interested. I'm past that now. So where am I? Arrow X shows the mean and median for parental variety. So these are parents A, and Y is parent variety B. Consider the following statement. Do you know what? I'd rather not. There is no significant difference in the length of the hybrid grains and the length of the grains in parent B. So this is the length of the grains there. So, describe any evidence from the graph to support the statement and name the terms what? Used to describe. Oh, I see. Well, let's do the evidence first. So, parental variety B has got its mean and median there. That's where the hybrids are. So it's closer to parent B than it is to parent A. So the evidence then is that the hybrids, remember this is our hybrids, these are hybrids here. This is why you need your paper open. Hybrids have a more similar mean, median. No, we weren't told the mean, were we? I'm going to cross mean out. Median and mode to parental type B. And I'm going to give it its full title because I've been told it. So that's our evidence ticked off. Describe any evidence. Name the terms used to describe the type of hypothesis represented by the statement, so no significant difference. That's a null hypothesis. And again, I'm going to write out hypothesis again because that's its full name. I think you might get away with just writing null. So type of, and the statistical test that could be used, so testing differences between the mean, t-test. Job's a good one. That's all three things done. Okay. Moving on. So now we've changed, look, we've changed letter from B. All the questions on B were all about the graphs, and we've changed direction now. So, as soon as fertilisation has occurred, the embryo and endosperm begin to develop with the plant redirecting products of photosynthesis to the developing grains. The longer the period of grain fill, so presumably this is the products of photosynthesis going in, the larger the wheat grain size. Makes sense? Grain size can be influenced by the availability of water, nutrients and disease management. With reference to the information above, explain the following. There is a saying amongst farmers, and presumably this is as well as Red Sky at Night, Shepherd's Delight. When you think the crop is ready to harvest, take a holiday. So this is obviously to do with the longer the period of grain fill. That's your information there. So it gives longer for grain to fill. And shall I put with products of photosynthesis? Yeah, I think so. Just going to get a better quality wheat, I think. The use of nitrate fertiliser. So this is a little bit on, I don't know what you would call it, synoptic. It's either synoptic from component 1 or it's synoptic all the way back to core. So plants absorb nitrate to make amino acids. I'm just going to list them now. Proteins, nucleic acids and chlorophyll. These, we're going to relate this to photosynthesis, aren't we? So this is the idea of redirecting the products of photosynthesis are used for growth of leaves, and now we're on synoptic really, I suppose, for component 3, leaf structure related to gas exchange and photosynthesis. So is more area. For photosynthesis, and more photosynthesis. And therefore photosynthetic product. And that's what you need to fill the grain up with. So then you're going to get grains with more amino acids in. Use of fungicide. So fungicides, these are going to kill fungi, obviously. So fungicides kill fungi. So plants have less disease. And therefore more photosynthesis. And photosynthetic products. I want to get that in as much as I can because that's what the whole thing's about, isn't it? About increasing grain size. So I just need to get that in as much as I can. It's probably only going to be worth 1 mark across the whole thing. You could have put there, I suppose, there's less nutrients, thinking about sort of, again, synoptically, there'd be less nutrients taken away from the grain if they didn't have any photosynthesis. Sorry, any fungi on them. But anyway, onwards and upwards. Here we go, bushels. In the USA, wheat prices are quoted per bushel, which is a unit of volume. In Europe, wheat prices are quoted per kilogram, and that, of course, is mass. Rex Ryder, made up name, is a Kansas farmer who harvests his wheat into a truck that holds 998 bushels. Really, I should have asked Miss Rojniak about this. I wonder if Rex Ryder is the one out of, yeah, I'm thinking Kansas, Dorothy. What is that film? The Yellow Brick Road one, anyway. So, anyway, never mind that. He harvests his wheat into a truck that holds 998 bushels. During the harvest, he fills his truck 22 times. Oh, we're going to have to do a calculation, I think. His farm covers 492 acres. Estimate, oh, so I don't need to calculate really, how many bushels of wheat he produced per acre to the nearest bushel. That's important. Don't want to be having any decimal points. Suggest 1 advantage and 1 disadvantage. Let's do the estimate first. So I'm thinking he's got around about 1,000 bushels. That's near enough 1,000. He's filled the truck 22 times. And then his farm covers around about 500 acres. I'm just going to do that then. And I'm going to get 44 as my result of that. Now, of course, you could put it in your calculator and check that your estimate is on point. And if you put it into your calculator, you'd be doing 998. And I know you, as soon as you see some numbers, your instinct is to grab your calculator, assuming you've taken one in. Sorry, was that a bit sarcastic? 492. So I've got 44, so I could have put 45 to the nearest bushel. That'd be 44.62, that'd be 45 bushels. So I made a bit of an underestimate there, but not by much. So the advantage of doing things by kilogram, what are we doing? Suggest 1 advantage per kilogram. Why do it by kilogram? So I think the wheat can settle over time. So you know, when this is the one I'm most familiar with, on a cereal box, they weigh it, but the cereal box always looks kind of half empty, and that's because it settles over time. so the volume's not brilliant, because you have to say this is the volume when it was put in. You could have put kilograms of SI unit and a bushel isn't. You could have put that it's more accurate to weigh it. Anyway, disadvantage. The disadvantage of using a kilogram is that you need really to dry the grains. To gain an accurate value. Because if you leave the water in, obviously the water weighs something as well, so not useful. You need to dry them first. Oh, do you want to see the colour picture of the grains? See, it was dead obvious. There's a yellow one, there are brown ones. The wrinkly bits look a bit more wrinkly on that.